I have substitution, and I have graphing. Those are my three methods for solving my system of equations. Which one do we want to use here? Elimination? Yeah, it looks like it's pretty much set up to do that already. We've got our R's lined up, our B's lined up, our equal sign lined up. What do I need to do in order to do elimination?
Set 1R plus 12B equals 50, multiplied by -3.
Okay, so I'm going to need to multiply one of my equations because right now if I add those together, neither of my variables cancel out. So what would I need to multiply one of my equations by?
-3.
-3? Okay, which equation am I multiplying? -3? Okay, so I want to multiply that bottom equation by -3. And when I distribute that out, I'll end up having -3R minus 36B equals -150. And now I want to combine that with that first equation. So just like I wanted, my -3R and 3R are going to cancel out. They'll end up being 0R. My -36B plus 30B will be -6B. And my -150 plus positive 132 should be 18. Is that right? Yeah, that's right. So I have -6B equals -18. And I'm solving for B, so my last step. Exactly. When I divide both sides by -6, I'll get B equals, +3. Okay, so right now I know that we sold 3 bouquets of 12 roses. That's what I know now. Am I finished? No, what else do I need to do? So I have to substitute my B value back in. Which equation do I want to substitute it in for? Sure? We could do either one. Okay, let's do the first one. So we have 3R plus 30. We'll put our B value in. We have 3 equals 132. And then I only have one variable left, R. So I want to solve for R. And I have 30 times 3 is 90 equals 132. I'll subtract 90 from both sides. Gives me 3R equals 42. And my last step, when I divide both sides by 3, I get 14. Is that right? Is that what you said? Great. Get 14. So, when I solved my system of equations, I got B is 3 and R is 14. And the question is asking me, does that mean that the $2 bill belongs in the cash box? How do I know? I'm going to check to see. So, my red equation is talking about money. My 3R plus 30B equals 132. If Jackson found that $2 bill, and put it back into the cash box, that would mean he's adding $2 to that. So if I substitute what I just found in, I have R is 14 plus 30 times 3. And this is with the $2 bill in the box. I would have 134. So 3 times 14, like we know, is 42 plus 90. On this side, when we added the $2 back in, we got 134. But 42 plus 90 is 132. So these do not equal each other. Does the $2 bill need to go back into the cash box? No. So when I put the $2 bill back in, that would make the total $134. But that is not equal to each other. So I would say no, the $2 bill does not belong in the cash box. I would say no, the $2 bill does not belong. It's 11. Yeah. The good long one. Oh no. Okay. We are going to, I actually cannot go back because it went away. Let's see.
I have a picture of it. I can send it to you.
I'll be able to put it on Canvas later, but because of the connection between the computer and the iPad.
I sent a picture of it to you.
Goodness. What is going on here? Okay, there we go. Okay, sorry, I will be able to put it back up on Canvas, and it's on the answer key that's on Canvas right now. But we will move on to number 11. I guess I should do this thing. Okay. Number 11 is a supply and demand problem. What is going on here? It says students in the College of Business at Butler University are looking to sell mugs with the Butler logo on the side. And they gave their professors this chart, this table, that gives following supply and demand information from previous promotions. So I have a price column, a supply column, and a demand column. And part A wants me to graph the supply and demand curves. So I know I'm going to want one for supply and one for demand. I know that my price is going to be my X value because I'm looking at how much the mugs cost. So I'm going to rewrite my supply X and Y values on the side. I'm going to have 150, 82.5, 2, 130, 3, 225, and 4 is 320. And I'm going to do the same thing for my demand, just to make it a little bit easier to look at. So I have the same X values. I have $150, $2, $3, and $4. And my Y's will be 382.5, 310, 165, and 20. So I have my X and Y tables, and I want to graph these curves. When I look at the grid, that's all it is a grid. I don't have a graph yet. I don't know where my axes are. But with supply and demand, I know that my price will always be positive. It's never going to be a negative price. And my demand could be negative, but doesn't really tell us much. So we don't need to look at the negative number of mugs. So I know that my grid is just going to be that first quadrant of the plane. So I can just put my X and Y axes along the sides down here. I just want to keep everything positive. Be positive. So my X values, I said those are my price. That's my money, my dollars. And my Y values are the number of mugs that are supplied and demanded. So those will be my number of mugs on the left. But when I look at my prices, I don't go any higher than 4 on my price. And so I'll just go up to about $5.
How did you decide your X's? Like Y and X?
So for supply and demand, I chose price as my x-axis because we can change the price of the mug. And when we change the price of the mug, it affects how many mugs are wanted. And we know that our x's are our independent variable. And so that's the one that when we change it, it'll affect the other one. So that's how I decided that for supply and demand. So I'm not going to go much higher than $4. So for this grid, I have about 20 squares on each side. I'm going to go $1 for every 4 squares. So 1, 2, 3, 4. That'll be my first dollar. $2, $3, $4, and $5. But on my y-axis, I know that I get pretty high up there. I get hundreds of mugs. Let's think this through. I have 22 squares. So I'm going to set each one at about 20 mugs. You could probably set them for 30, and that would work, or 50, anything around there. But we know we're going to need at least 400 mugs because our highest is 382 there. So if each one of my squares is 20 mugs, that means every 5 squares is 100 mugs. So I have about 400 mugs on my graph. Again, this is how I'm choosing to do it, to represent it. It doesn't only have to be this way. If you wanted to scale it a little bit different, as long as you have most of the information, that'll be okay. But now that we have our graph labeled, we can go ahead and plot our points. So for our supply curve, we have the point 1.5, 82. That'll be right about there. Maybe even a little lower. And our next point, I'm looking over here. Our next point is $2 and 130 mugs. That should be about there. Then I keep going. I have $3 will be about 225 mugs. And when mugs cost $4, it's at 320. So that's right there. And then I can go ahead and graph my line. Yes. How did I graph my first point? So I'm looking at each one of these X, Y's. Here I have $1. Each tick mark, because there's $4 or 4 squares in $1, is going to be a quarter. So 25 cents each. So I have halfway is 1.5, 150. Does that make sense?
On the y-axis, the highest number, which one is it?
This one says 400.
The one before says 500?
That says 300. I'm sorry. Let me see if I can fix that. 300. Maybe 20. Sorry about that. That's a 300. So I have my supply curve graphed. And I want to do exactly the same thing for my demand curve. So when mugs are $1.50, that'll be at this tick mark halfway between 1 and 2. Just, by the way, tomorrow on your test, you can have access to your colored pencils, rulers, calculators, anything that'll be helpful in that way. So I'll go in between 1 and 2 on my x-axis, and I want to go all the way up to 382.5. My next point is when mugs are $2, the demand is 310 mugs. When mugs are $3, people want 165 of them. And when mugs are $4, only 20 mugs are demanded. And I can graph my line. So, tomorrow, what I forgot to do, but if you're not using different colors, you'll want to label each. This one is supply, and this one is demand. You'll want to make sure you're labeling both. Part B says if the students set the price for mugs at $2 per mug, how many customers will be disappointed? How many disappointed customers will the promotion have? So I have a few places that I can look. One is on my graph. I can look at if the mugs are $2. That'll be up here. So it would be right there and right there. The other place I can look to be more precise is in my table, because they give me the exact supply and demand for $2. And I want to know what the difference is between the supply and demand if the mugs are $2. So if 310 people want mugs, but they're only going to make 130, they only supply 130, I want to know what the difference is there. So I subtract it. And I would know 310 minus 130, there will be 180 disappointed customers. So I looked at the difference between the two. Disappointed customers. Then part C tells us to estimate the point of equilibrium from the graph. So what does the point of equilibrium look like on a graph? Yeah, it's that middle part where they're intersecting, where the lines are crossing. So right there is my equilibrium. And I just look at that and I think, okay, X looks like it's 3/4 of the way between 2 and 3. So I'll say that's 275. And Y looks like it's right about that 200 mugs. So this is an estimate. If you said 260 and 190, or if you said even 3 and 225, anything around there within a reasonable range is a good estimate. Part D asks us, using the table, determine the equations for the supply and demand lines. What form do we want to write our equations in? Yeah, I like y equals mx plus b. We know how to write that one. So for y equals mx plus b, my slope-intercept form, I need to find two things. I need to find my slope, and I need to find my y-intercept. So to find my slope, this is to find my slope, I do my change in y over change in x, or y2 minus y1 over x2 minus x1. That is how I'm finding my slope. So I need to pick 2 points for my supply first. So I'm going to look back up at my supply table, my x and y table. And I'm just going to pick 2 points. I'm going to pick those ones at $2 and $3. But it doesn't matter which ones you pick. So this is going to be my x1, and 130 will be my y1. And then 3 will be my x2, and 225 will be my y2. So to find the slope for my supply equation, I would do y2 minus y1. That's 225 minus 130 over x2 minus x1, 3 minus 2. That is a 3. And when I do 225 minus 130, I should get 95. So my slope for my supply is 95. 95 over 1. But now that I know my slope, I need to find my y-intercept. So I'm going to pick a different one of my XY points. I'm going to pick that first one. Doesn't matter which one I pick, but I'm going to use that first one at $1.50. And I'm just going to plug it into a y equals mx plus b equation. So my point that I'm using, 1.5 comma 82.5. I'm going to plug that into y equals mx plus b. So my y would be 82.5. My m, I know that now. I just found my slope. My 95. For x, I'm going to plug in that $1.50 because that's the point I chose. But I don't know my b yet. That's what I'm trying to solve for. But then I just solve for b. So I have 82.5 equals 95 times 1.5 would be 142.5 plus b. And when I subtract 142.5 from both sides, I'll get negative 60 equals b. So I can rewrite it now with my slope and my y-intercept. And if I'm looking at that and I think negative 60 is my y-intercept, I can actually look at my graph and I can tell that it doesn't cross the y-intercept until below my x-axis. So negative works. Negative kind of makes sense there. And then I get to do the same thing for my demand equation. So we already know what to do for slope. We're just going to pick two of our points. For this one, maybe I'll pick when x is 3 and 4. So I have 3, 165, and 4, 20. And to find my slope, I would just plug those in. I have 20 minus 165 over 4 minus 3. And 20 minus 165 will give me negative 145. So my slope is negative 145. And now I do what I did for my supply equation. I pick another one of my points. This time I'm going to choose this xy point to 310 because it doesn't matter. I can choose whichever one. And I will plug that in for my y equals mx plus b equation. So I just found out that my m, my slope, is negative 145. I substituted y, which was 310. I substituted that on this side of the equation. And then I'll substitute my x. My corresponding x there is 2. And I'm solving for b. So when I solve that for b, I have negative 145 times 2, which gives me negative 290. Negative 290 plus b, and when I add that to both sides, I get my b value, my y-intercept is 600. And that means I can rewrite it as y equals my slope, my negative 145, x plus my y-intercept 600. And if I look at my graph to make sure, that makes sense because it doesn't cross until it gets all the way up to 600, which is off our graph. And the line is going down across the page, so that negative slope makes sense too. Okay. I'm gonna let you write for a little bit, but I will have to switch screens so that we can look at the bottom part of that problem. So if you want to take a picture of that now, before I move on, you can do that. Or it'll be up on Canvas tonight. Miss Bolt, would you mind scrolling down?
I'm sorry, to which one?
To E and F.
To the bottom.
Thank you. So, don't fail on me now. All right, so we'll move down. And we just found our supply and demand equations. Y equals 95x minus 60, and y equals negative 145x plus 600. So before we used our graph to estimate our equilibrium point, and now they want to know exactly what it is. And I have two equations. I have substitution method and elimination method. Which method seems the best for the way I have these set up now? Substitution. So I would set it up. I have 95x minus 60 equals negative 145x plus 600. And I want to solve for x. So I would move my like terms to the sides together. I'm moving them all in one step, but what I'm doing is first putting the 60 on this side and then moving the 145x over there. And when I solve those, I would have 660 and 240x. Which would give me x equals 2.75. My last step is to plug it in. So I could plug it in for either one. I'll put it into this first one, minus 60. When I put all of that into my calculator, I get 261.25 minus 60 equals 201.25 for y. So my solution, 2.75, 201.25. And that tells me that if mugs cost $2.75, both the supply and the demand is at 201.25 mugs. Okay.